us, and we're talking about our Lewis dot structures. Oh wait, that's a terrible way to write Fleming. So I'll just put this up here. So our Lewis dot structures are to show valence electrons or bonds. So we kind of have them maybe for an individual atom, or we'll have them for a whole mess of them and how they link together. And these tend to be our covalent compounds, or sorry, covalent molecules that are going to have the Lewis structures. And it's pretty easy to get this going. The valence electrons are for non-transition metals. The transition metals, it will list what it is, and they don't tend to be in here much, but it is group number or group number minus 10. You have 4 spots to place the electrons, and you want to fill one, or you have 4 spots, each can hold 2 electrons, so you kind of fill around a clock. You don't have to call it a clock. So you're going to fill around. For example, we have, I don't know, somebody give me a fun element. Hydrogens are starter, but what's a fun element?
Uranium.
Magnesium.
All right, we're going to do magnesium. Uranium is not going to work because that's in the middle. It can't be the guys in the middle yet. We'll get to that in a second. Give me another fun element.
Carbon.
Carbon. And I like bromine because it's fun to say. So hydrogen is super easy. What's its group number?
1.
1 dot. Magnesium is in group 2. It can get 2 dots. Carbon, what group is that guy in?
4. It's 4 dots.
Yeah, it gets 4 dots. It might be in group 14 or in group 4A, depending on what your periodic table is. And when we say fill around, it's going to get 1, 2, 3, 4 dots around it. The thing that most people do at first that's a little wonky is they'll do like all 4 dots crammed together. And the electrons repel each other, so we're not allowed to get them that way. So we've got 1, 2, 3, 4. Bromine is way crammed over on the edge. It's going to get 7 dots. Now, I know 7, so I could fill it pretty directly, but I'm still going to go around 1, 2, 3, 4, and then 5, 6, 7. Now, it's super easy to do individual elements. Now, when we're putting guys together, hang on, I got to change the size so it's not giant. We're going to connect the dots. You want to link elements to try to give them 8 valence electrons. I mean, that's what they're trying for. We tend to put one guy in the middle to start with. If you have a whole bunch of stuff, it gets a little bit more confusing, but I would say that carbon tends to be central or chains. Carbon chains are a hugely important thing. But if you look at bromine out there, bromine only has 1 electron available for bonding. So bromine is never going to be a central atom in something. So you do tend to see, you'll see people write things like most metallic is central. And that does break down at some point, but there are reasonable arguments for that sort of thing. But this is the most important part. We're just going to try it, and we're going to make some mistakes, and that's going to be fine. So I don't know, what kind of compounds do we want to talk about? If I do caffeine, that's way too complicated at first. Water is super easy and basic. All right, I got it. So, do you all know about the hole in the ozone layer?
Yes.
That's a product of things called CFCs. Those are compounds that are kind of CFCl. We've got, it's a carbon, fluorine 2, and then chlorine 2 down there. So we got people trying to come into the wrong class again. Sorry about that. So when we draw these guys, you can do the individual kind of carbon, fluorine, chlorine stuff, and you can put all the dots out. This is going to look like a really weird football play as I'm doing it. Mostly because I put the carbon in definitely the wrong place to start with, but it's kind of to demonstrate the point. So carbon's got its 4 places right there, and these guys all get 7 around, and I know I'm breaking my own cardinal rule right now. And is this pretty at all? Be honest with me, you're not going to hurt my feelings.
No.
No, it's not. Does it matter that it's pretty right now?
No.
Good. Yeah, because we're gonna make it that way. But literally, you just connect the dots. So the carbon can attach to that chlorine, and it can attach to that chlorine, and it can attach all the way over here to the fluorine. And then I put this one a little bit more accessible on the bottom. Now, if you turn this guy in, this is not going to work. This is terrible looking. It's fine. If you have a touchscreen, like if you're working on an iPad, you can do this with your own finger, which is way better than what I'm trying to do here. But I'll rewrite the carbon. I'll put a chlorine here, and I'll put another one here, and I'll put a fluorine here, and another one here. And then they just get connected with a line to the carbon, like that. And I can go in then and add all of my extra dots. And, you know, it's still not pretty, but we're working with the technological limitations we have. If you're writing this on your own piece of paper, you're going to get much better results than doing it on the screen. It's just when we're collaborating with each other, this is the space that we're working in right now. How are we feeling about this so far for the people for whom this is brand new? Good. This is kind of easy mode. Ready for something a little bit tougher?
We're doing uranium now?
All right, see, you're just gonna watch me tab over to find out what uranium's number is. Hang on.
$238.
I don't need the atomic number. I need what
82.
its ionic number is.
Oh.
So uranium is a 2+ ion. Oh no, the uranyl ion is uranium oxide. Okay, U4+ for uranium. So our uranium is gonna look like this. U, it's gonna be 1, 2, 3, 4. Although realistically speaking, it's making ionic bonds with things, so we'd have a polyatomic ion with some stuff in there that would make it behave better. Easy one is methane. That is CH4. When people talk about making meth, this is not it, but we say the word meth and it's just a CH cluster on the outside of things. The next one on the list is C2H6. This is ethane. I want you guys to try to draw out C2H6 because CH4 is stupidly easy. You just have a C and you have 4 H's on it. Don't be shy. Grab that annotate tool, start writing it out. And if you've done this before, I'm going to make a harder one over here. This is going to be orange. And an even harder one here. All right, now I'm serious. Do you guys not know where the annotate tool is on this thing? You can say no. Oh, Mario found it. Good. We do know where it is. So I want to start with this C2H6 business. And if you've done this before, go ahead and do one of the harder ones so you can get a feel for it. But start, I mean, you can just kind of write out what you have going on here, but you got to get your elements to work with each other. And H's will bond H to H, but they're kind of a dead end every single time that you do that. So they can't, they're kind of ends of things where our carbons can touch each other pretty easily. So I'm waiting for somebody to draw some carbon out for me. There, we got it. Now the one thing, Nathaniel, is that there's only one line connecting the carbons in this particular orientation. There you go. That's what we call ethane. Do you guys like music? Ethane is our precursor petrochemical to making vinyl for records. Vinyl's a ethane chloride chain. I'll give another kind of moderate one to get going with it. This is just terrible for me trying to write this out. C4H10 is propane. My buddy Hank taught me all about that. All right. So we only have one C here. I don't know where this other guy came from. It looked good though. Yeah, you're on the right track, Zane. And no, you were going all right with the propane too. That's the right track. Now, with all of these, you just have to kind of give them a shot, is the thing. And I know we all feel like we don't want to look dumb in front of everybody when we do this, but you just kind of give it a shot and see what happens. Now, it is a function of carbon that it loves making long chains of molecules. That's just a carbon thing. And this is big for organic chemistry. This is how it all works out. Yeah, so then you just have to see, do you have a place for 10 H's in that shape? And it looks like Adrian's working on acetic acid. No, what is that, Adrian?
Right?
Huh?
On this C.
Yeah, that's right. After drawing a few long chain carbon things, you learn the lazy way to do it, which is you draw a little bent line and each node is theoretically part of, that's a carbon that is surrounded entirely by hydrogens because that's how they tend to be found. So this guy that took Mario a while to write out can also be written just as boop, boop, boop. I mean, I'm not expecting you to know that coming into this, but we got some lazy ways to do it. Adrian, you need another oxygen in there somewhere, and that makes everything difficult, I know. Oh, wait, I gave you the wrong formula. So one of the things when you write it out is you just got to kind of try things, and you might get yourself into some corners. And trying to get people to try is the hardest part of my job at this point. But we will get it, and it will work out. When we are seeing these long molecules, we want to remember that all the hydrogens tend to have a mild positive charge because all of their one electron has moved in toward the carbon in there. So when you get some things that have a free oxygen over here, this guy has 2 electrons on his end, and he's actually kind of sucking the electron off of the hydrogen and the general electrodensity off of the rest of the molecule as well. And this is going to come up. But these, the way that the electrons all get moved to one side, do make the molecules do weird and interesting things. This guy right here, that is why you do not drink moonshine. It is a natural product of alcohol creation, but it will make you blind if you drink it. It's called methanol. But there's something about the way that it strips all the electrons over this way that it does very bad things to parts of your brain when it gets inside. But we are out of time right now. So when we come back tomorrow, we'll have something a little bit more group work interactive for you guys. And yeah, if you have any questions, you can hit me with them, and otherwise have